Okay, so this is definitely the number one question that I've received this week so far in terms of getting some help with it. So I figured I'd go ahead and help you. Now, obviously, right from the start, we can see these inequality symbols right there. So we're definitely going to have to use some sort of inequality here to try to figure things out. All right. Also, another thing you have to remember, my question is going to be a little bit different from yours in terms of numbers. However, it's the same type of question, which means if you do your problem along with what I'm doing, you should be able to model yours exactly the way I am. Okay? So I'm going to go ahead and read the problem, and then we'll go for it. We'll solve it from there. So the sum of the lengths of any two sides of a triangle must be greater than the third side. If a triangle has one side that is 11 inches and a second side that is 4 inches, less than twice the third side, what are the possible lengths for the second and third sides? Now, when we look at this, all right, this question doesn't say anything about, this is the specific side of the triangle. For example, you don't know if this is a right triangle. You don't know if it's an equilateral triangle. You don't know if it's an isosceles triangle or just some regular arbitrary triangle like this. You have no idea, okay? So you don't have to worry about really drawing a picture, but what you do have to worry about, and this is the whole problem right here, all right, is this very first sentence that says the sum of the lengths of any two sides. Any two. So it doesn't matter what two you add, that has to be greater than the third side. Now, like I said, we don't know, which one's side one, what's side two, and what's side three. We have no idea. Now, what we do know is this. We know one of the sides, we'll call it side one, or their first side, is equal to 11 inches. Like, we know that. How do we know that? It's right here. It's given to us in the problem. We also know side two, a second side, there's the is, so we know the second side is equal to 4 inches less than twice the third side. So 2x minus 4 inches. The only thing this problem doesn't tell us at all is what is the length of that third side. So when we don't know something in math, we abbreviate it as x. Okay? Now that we've identified our three sides, what we're going to do is we're going to try to find a relationship between all these three sides and that very first sentence in green, which says the sum of the lengths of any two sides of a triangle must be greater than the third side. So we can say side one plus side two must be greater than side three. Okay, that's the first idea. Now, I'm not saying this is the correct, but this is exactly what it is saying. So let's go ahead and let's try to figure this out. We know side one is 11. We know side two is 2x minus 4. And this has to be greater than x. Now from here, what we're going to do is we're going to solve this just using our basic properties of linear inequalities. So I'm going to go ahead and group my like terms on the left-hand side. So I'm going to get 2x, 11 minus 4 is positive 7, which is greater than x. Okay? Now I'm going to subtract 2x from both sides of my inequality. That's going to give me 7 is greater than negative x. I'm going to divide both sides by the coefficient, which is negative 1. That's going to give us negative 7 is less than x. And to be honest with you, I really like reading my inequalities from left to right, and I really want the variable to be first. Notice that this inequality symbol, if you create it like a little arrow out of it, it's pointing to the negative 7. So what I'm going to do is I'm going to rewrite this as x is greater than negative 7. In other words, I'm going to make sure that that inequality symbol, is still pointing at the negative 7. Now, hopefully, you were looking at this and going, wait a minute. How can the length of a triangle be negative? And I agree with you. The only thing that this is telling me is maybe these two sides are not the sides that we should be adding up. Okay? So we're going to have to find another adding two sides up and make it greater than the other side. All right. So this is a great thing, to be honest with you, because now we're narrowing down what we're looking for. Okay. Because remember, we have no idea what this triangle looks like. So how about we do side 1, and we're going to add side 3 together and make that greater than side 2. Okay. We know side 1 is 11. And we also know side 3 is x. Side 2 is 2x minus 4. Okay? Now let's see what happens here. There's nothing I can group on a left or right, so I got to get variable terms, constant terms together. I'm going to subtract 2x from both sides. That's going to give me 11 minus x is greater than negative 4. I'm going to subtract 11 from both sides. That's going to give me negative x is greater than negative 15. And now I will divide both sides by negative 1 to give me x. We're dividing by a negative, so the inequality symbol flips. X has to be less than 15. And that is a valid answer because it is positive. So here's what we know. I'm going to scroll up so we can see this. We know that either the second side or the third side, or better yet, I don't even want to say that. What we know is this third side, okay, has to be either greater than 15 inches or less than 15 inches, all right? The only way that we're going to know where this number appears or where the 15 goes is by finding the other ones, okay? So far, we know side 3, and one of those numbers is 15, okay? We also know side 1. Side 1, no matter which way you look at it, is 11 inches. So what we can do is take this value of 15 and figure out what side 2 is. Because side 2 is right here. I'm going to highlight it for us. Side 2 is right there. It's 2x minus 4. So, get out my marker here. Side 2, and I'm just going to do the math underneath here. Side 2 is going to be 2 times 15 minus 4, which is 30 minus 4, which is 26. So I know side 2 has a 26 in there. What I need to do now is do this one more time, except instead of using side 1 plus side 2, instead of using side 1 plus side 3, we're going to do side 2 plus side 3, and that has to be greater than side 1. Okay? We know side 1 is 11. We know side 2 is 2x minus 4. And we also know side 3 is x. So from here, all I have to do is solve this inequality. So 2x plus 3x, 2x plus x is 3x. Minus 4 is greater than 11. Now I'm going to isolate the terms. So I add 4 to both sides. I get 3x is greater than 15. And when I divide both sides by 3, I get x is greater than 5, which is our third side. So I can scroll all the way back up. Now I know side 3 has to be in between 5 and 15, because 5 is obviously lower than 15. And I also know side 2 is going to be 2 times, what was it again? I forget already. 5. Okay, perfect. 2 times 5 minus 1, which is going to be, what is that? Oh, no, minus 4. Sorry. Typo. Minus 4. 10 minus 4 is 6. So, second side is going to be in between 6 and 26 inches. And then the third side is going to be in between 5 and 15 inches. And that is exactly how you do the problem. The sum of the lengths of any two sides of a triangle must be greater than the third side. What you had to do is figure out what two sides are you actually adding to find this. Okay? So I hope this helped, and I will see you in the next video.